Good morning to one and all. So we will start with our lecture now. Let me share my screen with you. Okay, so today we are going to see the next bit, that is nothing but the Openstack. Hope my screen is visible to you and also I'm audible to you properly. So we will start with Openstack. Okay. So Openstack, it is a free open standard cloud computing platform, and it is mostly deployed as an infrastructure as a service, that is IaaS. That is like whatever we saw yesterday, that is cloud stack. It is also giving the same service for infrastructure as a service in both public and private clouds, where the virtual servers and other resources are made available to the users. So the software platform consists of interrelated components that control the diverse multi-vendor hardware pools of processing, storage, and the dashboard through command line tools or through RESTful web services. Okay, so you can use any kind of a platform that is command line or RESTful web services. So we will start with introduction for the OpenStack first. So OpenStack is a cloud OS that is used to control the large pools which are the large pools of computing, then storage and networking resources within the stipulated data center. So OpenStack is an open source and free software platform which is essentially used and implemented as an IaaS for the cloud computing. So we can call the OpenStack a software platform that uses the pooled virtual resources to create and manage private and public clouds. So OpenStack offers many cloud-related services such as networking, storage, image services, identity, etc., which are the by default. So this can be handled by the users through web-based dashboard, which just now we have seen, like the RESTful API, application programming interface, or the command line tools. So OpenStack manages a lot of virtual machines, which permits the usage of physical resources to be reduced. So basic principles of OpenStacks may include like basic principles of OpenStack. So they are open source, means like under the Apache 2.0 license, the OpenStack is coded and it is published. So Apache will allow the community to use it for free. Then open design is there. So for the forthcoming update, the development group holds a design summit every 6 months. So it is getting updated on every 6 months duration. Then open development. So open development, the developers maintain the source code repository that is freely accessible through the projects like Ubuntu Linux distribution via NT 100S. And then open community. So OpenStack allows open and transparent documentation for the community. So if we go through the OpenStack, so as per the OpenStack Foundation, OpenStack is a global collaboration of developers and cloud computing technologists, which are producing the ubiquitous open source cloud computing platform for public as well as private clouds. So mission behind this is to produce the ubiquitous open source cloud computing platform that will meet the needs of public as well as the private clouds regardless of size. Then by being simple to implement and massively scalable. Scalability, which is one of the feature of cloud computing. So it will be found in case of OpenStack massively. Then next is OpenStack components. So we will go with the components of OpenStack. So the components are involving the computing, like compute. For the compute, we can use Nova, image, glance, storage. For that, the block storage is there, that is Cinder, and object store is there, that is Swift. And for networking purpose, Neutron will be used, and management, which will be done by the Horizon. So in detail, we will see these all components. So this is the basic structure or the architecture used for OpenStack. So here in the figure, you can see the components of OpenStacks. So first of all, the OpenStack components. So as we saw here, the compute is there, Nova. So compute is the controller that is used to manage the resources in the virtualized environment. So it handles several virtual machines and other instances that perform the computing task. Then object storage, that is nothing but the Swift. So to store and retrieve the arbitrary data in the cloud, object storage is used. So in Swift, it is possible to store the files, objects, and backups, then images, videos, virtual machines, and other unstructured data. So developers may use a special identifier for referring the file and objects in place of path, which is directly pointing to a file that allows the OpenStack to manage where to store the files. Then block storage is there, that is Cinder. So this will work in the traditional way of attaching and detaching external hard drive to the OS for its local use. Cinder manages to add, remove, create new disk spaces in the server. This component provides the virtual storage for the virtual machines in the system. And then Neuron, that is used for networking purpose. So it is this particular component. This component is used for networking in case of OpenStack. So Neutron manages all the network related queries such as IP address management, routers, subnets, firewalls, virtual private networks, VPNs, etc. So it confirms that all the other components are well connected with the OpenStack. Then coming to the next, that is nothing but the horizon. Actually, it is not listed over here, but horizon, which is the dashboard used for this. So this is a first component that is used. It is the first component that is used that it will be used for the for checking whether the user sees in OpenStack. So Horizon is the web UI, web user interface component used to access the other backend services. So through the individual APIs, developers can access the OpenStack components, but through the dashboard, system administrator can look at what is going on in the cloud and manage it as per their needs. Then identity services, that is Keystone. It is the central repository for all the users and their permissions for the OpenStack services which they are using. So this component is used to manage the identity services like authorization, authentication, then AWA styles, logins, token-based systems, and checking the other credentials like username and the passwords, etc. Then next is the image service, that is nothing but the glance. So the glance image service, the glance component is used to provide the image services to the OpenStack. So here the image service means the image or virtual copies of the hard disks. So when we plan to deploy a new virtual machine instance, then the glance will allow us to use these images as the templates. So glance will allow the virtual box, that is VDI, then VMware's raw Hyper-V and KVM virtual images, etc. Then telemetry, that is Ceilometer. Just 1 minute. So these are the components in which we are looking into. So we have seen the Nova, that is nothing but the compute. Then we have seen the object storage, that is Swift. Annotation the problem मध्ये. Then we have seen for image services the glance. Then for networking, that is quantum or the networking process. Then block storage, that is Cinder. Then we are coming to the next, that is nothing but identity services, that is Keystones. Then telemetry, we have seen orchestration. So we are here at telemetry. So celometer is there, which is used to meter the usage and report it to the OpenStack's individual user, that how much data you have used. So it is like a meter. So basically telemetry provides the billing services to the OpenStack's individual users. Then orchestration is there, that is nothing but the heat. So it allows the developers to store the cloud's applications necessities as the file so that all the important resources are available in hand or in handy fashion. So these components organizes many complex applications of the cloud through the templates via both the local OpenStack REST API and query API. Then there is a shared file system. So it offers the storage of the file to a virtual machine. This component will give the infrastructure for managing and provisioning the files shares. And finally, the elastic map reduce is there, that is called as a Sahara. So the Sahara components offers a simple method to the users to pre-planned Hadoop clusters by referring to the multiple options such as the Hadoop version, cluster topology, and hardware details of nodes and many more. So this is the, we can say, basic structure of OpenStack. And now we are coming towards the architecture for OpenStack. So if we go through the architecture, so here is the architecture of OpenStack. So we will see all the points related to that one by one. Yes, okay. Okay, so out of that, the first one is the Nova, which is also called as a compute. Annotations get hidden after some time. I will use a better way, this particular use. So first is the Nova component, that is nothing but the compute. Here it is. So compute, Nova is one of the most common It is the most common and important component of the OpenStack. Compute is the controller that is used to handle the virtualized environment resources. So Nova is written in Python language. VMware, Zen, KVM are the hypervisor technologies that could be used here. And this choice is contingent to the OpenStack. So the functionality provided by Nova is the Nova API processes the request and responses to and from the end users. So when a request is submitted, the Nova generates and removes the instances. Nova scheduler schedules the Nova compute jobs. Then the glance registry, along with its metadata, it will store the image information. Then the image will store the predefined image for the user or the admin. The Nova network assures the connectivity and routing of the network. Okay, so this is the task of Nova. Then coming towards the next, that is glance, or also called as the image. Next part is nothing but the image. So the image, the instance of virtual machines or the disk image are stored as the images in the image store glance. So this component will offer the image services to the OpenStack. Here the image services means the images on or the virtual copies which are present on the hard disks or the virtual copies of the hard disks itself. So when we plan to deploy a new virtual machine instance, Glance will allow us to use these images as the templates. Then next part is the Swift or the object storage. Object storage. So what is the use of object storage is it is the mountable storage unit of this particular architecture. So it helps in data replication across the data center. So whatever the data replication which is must in case of damage to your data center or some kind of attacks on the data center, at that times some kind of replicas we maintain. So maintaining these replicas, our Swift or the object storage will be used. The files and the objects can be copied to multiple units with the help of this unit, that is the object storage. So the object storage units are replicated with every new server addition. So whenever you add any new server in the system or in that particular cloud, so to make its replication or replica is the task of Swift. It also stores the replicate content from all the active nodes and make it available to the new cluster, ensuring the backup in case of any hardware failure or server loss. So that's why it is very important. So to store and retrieve arbitrary data in the cloud, then object storage. So for that purpose, object storage will be used. So in Swift, it is possible to store the files, objects then backup images, videos, then virtual machines and other unstructured data once again. Then coming to the next, that is Cinder or the block storage. Next part is the Cinder, or we can call it as a block storage. So block storage, it will provide the persistent level storage facilities for cloud oriented computing devices. So it helps in the creation, addition and removal of the new block entries, block devices in the server. So it provides the complete integration with the OpenStack. It reduces the use of extraneous hardware components. So it can be accessed and instructed using CLI or any web-based services. So Linux-based systems can go with CloudByte, EMC, SAN storage, etc. So this work in traditional way of attaching and detaching an external hard drive to the OS for its local use. Then also Cinder manages to add, remove, create new disk space in the server. So this component provide the virtual storage for the VMs, virtual machines present in the system. Then next is the neuron, or we can call it as a networking. Network or the neuron, we can call it as a neutron also. Somewhere it is written as a neuron and somewhere it is written as a neutron also. So this is responsible for establishing a neuron structure between the components for better connectivity. So it manages all the networking related functionalities of the architecture as a whole. So starting from assigning and managing the IP addresses of the nodes to managing and implementing routing algorithms. So it constitutes all. This neuron or networking will constitute all this. So this component is used for absolutely for networking in OpenStack. So neutron or neuron manages all the network related queries such as IP, address management, routers, subnets, firewalls, VPNs, etc. So it confirms that all the other components are well connected with the OpenStack. Then coming to the next, that is nothing but the horizon or the dashboard. Horizon or the dashboard. So this is the first component that is the user, through which the user can see the OpenStack. So horizon is the web UI, web user interface, that component which is used to access the other backend services. And finally, the keystone, or we can call it as a identity. This one, identity. So it is the central repository for all the users and their permissions for the OpenStack services they use. So this component will be used to manage the identity services like authorization, authentication, AWS styles, logins, token-based systems, and checking whether the other checking the other credentials like the usernames and the passwords. Okay. So clear with the concept with all these things which are very, very important from the architectural point. If you have a theory paper for this subject, then this is the must question, that is explain the OpenStack architecture. So here with the identity, you can find all, that is nothing but the, after getting authentication, all the other parts are getting authenticated over here. So provides authentication for. So after getting the authentication only, you will be getting the other accesses. So block storage, it will provide the volumes for what? So the compute. Then for network is responsible for providing the network connectivity for what? Compute again. Then this network will provide the user interface for what? For the dashboards. This will again provide the UI. So everywhere it will providing the user interfaces. Here also, all the components are providing the user interfaces. You can see over here from the network also, you are getting the UI. Here also, here also, here also, and here also. So from all these, that is from network, block storage, compute, image, and block object storage, you are getting the UI to what? To the dashboard. Through the dashboard only you are going to access the system as a whole. But to have the access to the database, dashboard, you have to first log in through the system, and that will be through your proper identity, that is your proper authentication. So it will be here, it will be showing you the provides authentication for what? To the dashboard. Okay, then after it will be giving you the connectivity through the network. So connectivity will be given to the compute. Images will be stored through this on the image part, then files will be stored over here. So if your ideas are perfect with the this particular structure architecture, then you can write your answer very well. So this is all the architecture part of the this what OpenStack. So the detailing we already have seen. So how does the OpenStack works? This point also will come. So basically OpenStack is the series of command which is called as a scripts, and these scripts are packed into the packages which are called as the projects that rely on the tasks that create cloud environments. So OpenStack relies on two other forms of software in order to construct the certain kind of environments. So virtualization means a layer of virtual resources basically abstracted from the hardware. And then a base operating system that executes the commands basically provided by the OpenStack scripts. So we can say all the three technologies, that is virtualization, base operating system, and the OpenStack must work together. So how it works, that needs to be discussed. So as we know, the horizon is the interface for the appliance environment. So anything that the user wants to add should use the horizon or the dashboard. So dashboard is a simple graphical user interface with the multiple modules where each module performs some specific tasks. So all the actions in the OpenStack work by the service API call. So if you are performing any task, it means you are calling a service API. So each API call is first validated by Keystone or the so you will have to log in yourself as a registered user with your login username and password before you enter to the OpenStack dashboard. So once you successfully log into the system, to the OpenStack dashboard, you will get many options to create the new instances, volumes, sender, and configure to the network also. So instances are nothing but the virtual machine or the environments. So to generate a new virtual machine, use the instances option from the OpenStack dashboard. So in these instances, you can configure your cloud. So instances can be Red Hat, Open, SUSE, Ubuntu, etc. Then again, the formation of the instance is also an API call. You can configure network information in the instances. You can connect these instances to the sender instance or the volume to add more services. And after the successful creation of an instance, you can configure it. You can access it through CLI, and whatever data you want to add, you can do it. So even you can set up an instance to manage and store the snapshot for future reference or the backup purposes also. And then coming to these parts we already have seen. So coming to the benefits of using the OpenStack. So out of that, the first, so there are actually a lot of benefits of OpenStack in this cloud computing platform. So we will see some of them one by one. First of all, it is open source. So open source is what? As we know, using the open source environment, we can create truly defined data center. So OpenStack is the largest open source platform. So it offers the networking, computing, and storage subsystems in a single platform. Some vendors, such as Red Hat, have developed and continue to support their own OpenStack distributions. So OpenStack source code is available at GitHub also. The two main advantages of open source OpenStack projects are: first one is OpenStack can be modified according to your rising demands as per your requirement. You can add the extra features to the OpenStack also. And secondly, it can be used without any limitations. So since OpenStack is freely available project, so there are no limitations or restrictions to the use of it. You can use it as per your requirement. So there are no limits for what purpose you use it, where you use it, or how long you are going to use it. Okay. Second benefit is the scalability. Scalability is the major key component of the cloud computing. Already in first unit, we have seen the features or the benefits of cloud computing, and in that the scalability point was highlighted. So OpenStack also offers the better scalability for business. So through this feature, it allows the enterprises to spin up and spin down servers on demand. Third is the security. One of the significant feature of the OpenStack is security, and this is the key reason why OpenStack is so popular in the cloud computing world. So with OpenStack, your data is always secure. When company owners want to move their IT infrastructure to the cloud, they always fear about the data loss. But there is no need to think about the data loss with OpenStack, as it offers the best security feature. And OpenStack provides security professionals who are responsive to the OpenStack's strong security. Then the next is the automation. So automation is the main key selling point of OpenStack when compared to the another options. Why OpenStack is getting sold more and more. So the reason is automation. The ease with which you can automate the tasks makes the OpenStack more and more efficient. OpenStack comes with a lot of inbuilt tools that make the cloud management much faster and easier. Then OpenStack provides its own API to or the application program interface that helps the other applications to have full control over the cloud. So this function makes it easier to build your own apps that can communicate with the OpenStack to perform the tasks such as firing up virtual machines, etc. Then development support. So since the OpenStack source code is freely accessible, experts from all over the world can improve the platform. So if a new feature is being designed, it can be built easily and professionally by the development team. Then OpenStack is like Linux in that have many distributions with different features but share the same component. Support from the companies. So for the development, OpenStack gets support from IT founders, including Intel, IBM, AT&T, Cisco, Red Hat, Dell, Ubuntu, and so on. So by this, it's changing, which is the massive benefit for you. Support from the developers community is also there. So that means the many developers are working on the enhancement of the OpenStack. They are continuously working hard to make the OpenStack better and better. Next is the easy to access and manage. So we can easily access and manage the OpenStack, which is biggest benefit for you. OpenStack is easy to access. And please mute your mic. It is easy to access and manage because of the features like command line tools. Varali, I think your mic is on. Please mute yourself. Swarali Bajibakri, mute your mic. Varali. So command line tools, we can access the OpenStack using the command line tools. Then dashboard is provided to you. OpenStack offers the users and administrators to access, manage various aspects of OpenStack using the GUI based on the dashboard components. So it is available as a web UI. Also the APIs. Please mute yourself. There are a lot of APIs which are used to manage the OpenStack. Is the services. So OpenStack provides many services required for several tasks for your public, private, and hybrid clouds. So list of services like OpenStack offers the list of services or components such as Nova, Cinder, Glance, Keystone, Neutron, Celometer, Sahara, and many more. So each component is used for different tasks, such as Nova will provide the computing services, Neutron provides networking services, Horizon will provide the dashboard interface, etc. Then strong community. OpenStack has many experts, developers, and users who love to come together to work on the product of OpenStack and enhance the features of OpenStack. And finally, the compatibility is also there. So public cloud systems like AWS, Amazon Web Services are compatible with OpenStack. So these are the benefits of OpenStack. So that's all for today. So if you have any doubt, you can raise your queries. Otherwise, we will stop here. You are having one session at 11 o'clock that is related to something like exam. So please put your attendance in the chat window. And if you have any doubt, you can ping me on my WhatsApp number. So that's all for now. That's all for today. So we will stop here. You can put your attendance and leave. Thank you very much. All the remaining students, put your attendance fast and you can leave. Pratiksha Mali, then Gayatri Dikshit and Sakshi Parudkar. Put your attendance.